Hey guys, how's everything going? This is Jay, sir. This is another episode on React internals. Today we'll look at the lazy function, the lazy API from React. I had actually used it before, but maybe not just with this raw API, but wrapped in some other kind of UI library. I don't remember exactly, but it should be very simple. We'll start with the demo here. So if we have this component and this app, we want to use this component inside of app, we could just import it and use it statically, right? Just as what we do usually. But this component just might be very heavy, and we don't want to import it. We don't want to download it and then evaluate it until we need it. If the component is hidden nested pages, right? So that's where we that's a perfect case for us to lazy load the component. So for this lazy API from React, we just use it with an argument of a promise creator. Here the delay is just forces the loading to for demo purpose. Actually, you could just import it. This import like a native dynamic import, it will return the imported objects and under the property default, right? Just for ES module thing. Anyway, so this is a new lazy component. We could use it as as you is supposed to be, right? And then this lazy component will lazily load this JS, dynamically load it, and then evaluate it. And yeah, and one thing is that if it is not ready, it suspends. So we need this suspends fallback. So here's demo. When we click this checkbox, it will set show, and show will be true. So this subtree will be put in the fiber tree, and then the lazy load component will kick in, right? It will start lazy loading, but of course, because it's falsely delayed, it will suspend. We will see the loading, and after a period of time, loading is down, and this component will be ready. So this suspense will re-render the this part, not this part. It will mark this one as re-render, but the whole app will be re-rendered actually. And then we will finally see the component. Let's see. Click it, loading, and yeah, this is some lazy component. And then when we run it again, you see there's just no loading because it will be cached. Yeah, it will be cached, and next time when we use it, it won't suspend anymore. I like to point out that you see that this pattern is load at rendering, right? But actually, it's not the most eager timing. For some cases, you need to preload the component to boost the performance. If you are, I don't know, if you have you're pretty confident that this component will be rendered sometime in the future, maybe not right now. You could just preload it, and next time when it's really rendered, it will have, because it's the component is already being downloaded. The suspense time will be shorter, and it possibly would create a better user experience. But it really depends on how your application is organized. Okay, so this is demo. So actually, we could actually implement this kind of lazy by ourselves, right? As we've already covered a few episodes on suspense. It's basically just this throwing the promise when it's not ready. So here's what I created. Lazy. I've created the module loader, and inside of it, I used an object to hold the module, the component, and the promise, which means it's being loaded or not. And this is the error. So this is an initiator when it's starting load. If this module is not, this module is there, we just use this module, so it will be synchronous. And if it is an error, we just throw this error. And so this when we use this load in the rendering of in the function component, this will throws, and we could use the error boundary to catch the error, right? And then otherwise it should be loading, right? But if this promise is null, it means that it's not loading, it's not started. yet. So we kick it off. So this promise will load, and then because the dynamic loading gives us this is module, we need to check the default stuff, and then we set the module. Otherwise, if none of this condition is true, it means that the it's still being loaded. The promise is there, and the module is null. And so we just throw this promise. Remember, when you throw a promise, the suspense boundary will catch the promise and attach the then callback, which when the promise is resolved, the suspense will schedule a re-render to reveal the contents from the fallback. So okay, so this module loader, after we're done, we could, like say, create a lazy function. Here is because this is the load initiator, right? We could just create a module loader, and then we write a new component. This is new component. This component will relate all the props to the original component, which is the component, which is the module we get here. So it'll load, yeah, because if it's ready, we just return this module. So actually, this worked pretty well, I would say. Maybe there's some, I don't know, edge cases, but cannot think of it yet. You can see that here, this is our lazy. This is our lazy API. We will use the same like delay, import stuff. It will render as previously. So click it, loading. This is the fallback. When it's ready, we'll review it with the content. And if we run it again, there's no loading. Pretty well. So this is not difficult, I would say. The thing is, I think if it is we can achieve by ourselves, there's no need for React to expose this kind of native API of a lazy, right? So let's dive into the source code to see why it's necessary. First of all, the lazy returns a special React elements. Remember the elements. I think it's pretty somewhere. Yeah, default when we create an element, it should be with the type of React element type. This is default one, like for the function components or the class component. But for lazy, you can see that it's a different type, right? Like lazy type. Means it's some special node on the fiber tree. Great, so this is the elements. Remember, this is the realm of React elements. It is a blueprint to tell the React to construct the fiber tree. So the fiber tree here, you can see that. Okay, so for the fiber tree, it actually because fiber tree is distinguished by its tag, meaning the type. I can see that it's for lazy, it is called lazy component. There is some sort of mapping, but it's not one-to-one. For example, for React element type, internally for fiber, it has subtypes like its function component or class component. But for the elements, it's the one React element type. Anyway, so here when we use the lazy function, we will return the lazy type, which is the special React elements. So let's see. Where is okay? So this element has this type, and then its payload. Payload is as similar to what we did here with here. It holds the data. Holds the data and the result status. It's slightly different from what we're doing. The status indicates whether it succeeded or loading or pending or something, right? And this is a result. I think it's done better job than us. We just use the three properties. I think the status one will be more clear. Clearer. Yeah, cool. And then it's returned, and this initializer is kind of what we're doing with our load actually. Let's take a look at the code. Lazy initializer, yeah, if check this status, if it is uninitialized, we will create a then callback right then, and then we'll load it, and then you will set the status and set the result. If an error, we'll set the status of rejected and sets the result. It's similar to what we did do with the error property. And then, yeah, it's basically doing the same. Here, if it is resolved, we'll just return the module. Otherwise, we throw. So I think it's better than our implementation, but basically we're doing the same. Cool. So, okay, we're talking about the element type and the fiber tag for the lazy component. We will see here how it's mapped. So when we create a fiber from the element, as I said, during the initial mount or re-render, the React elements, which is the return of the function components, are the blueprint indicating the React runtime for how to construct those fiber nodes, right? So here, create fiber from elements, we could see that fiber, let's create fiber from types and props. Yeah, this is the branding props, is the React elements. You can see here, for the type, this function, we use the class component. Yeah, of course, it checks the construct as well. If this, otherwise, I think it should be a function somewhere. Default is somewhere. It's not here. Anyway, if it is string, it means that it's the DOM, right? The intrinsic DOM. So fiber tag is host component. Host means the host DOM environment. And by default, if it is an object, it's like it's some special type of we checked, blah, blah, blah. You can see here, if check if it's React lazy type, it's the element type. And then we will get the tag, break, get tag. Fiber tag is lazy component. Yeah, this actually does the mapping. It's pretty raw, I would say. Okay, so now from the React element, we're able to create the fiber. So next step is figure out how the fiber works, right? Basically, each time we check the fiber or any hook stuff, we could think how would it work on initial mount and re-render. It's all under the beginning work here. For lazy component, it's only one mount. Okay, for some fiber nodes, is only one function will be enough. So in this mount lazy component, we could see what it does. It gets the element type. Yeah, as pointed out here, the type is actually this. So it's an object holding a payload and initializer. Yeah, so we get the element type lazy component, and then we get the payload and init, and then we init it. This is similar to what we did in our implementation, as we just call the load, right? We call here, yeah, we module loader and load. Here it's actually the same. It's init the payload. Obviously, as we talked before, if it is not ready, and it just throws, so it actually will be stopped here through an promise, and it will be called by the outer suspense boundary. Okay, if it is ready, we'll continue. So here is something we didn't do. It will resolve the tag. What does it do is actually resolve the tag here. We check the type of the component and return the fiber tag. So this is the fiber tag. The component is the lazy, the original component that's be lazily loaded. So it gets the tag, and depending on the tag, it will, like say, aggressively try to reconcile its children, and then return a child of these children. So it returns the grandchildren of this lazy component. Yeah, so this one is basically similar to what we had in the begin work. Actually, for the begin work, there are other switch cases covering this. So yeah, and this throws an error if some element type other than this listed here are promises. For example, lazy component should not load lazy again. Great. So here is something. Here's all the implementation of the lazy. To be fair, it's pretty similar to what we did. The one mystery is that why it's necessary. I think from my observation on the source code, I would say there are two reasons. The first one is you can see that there is a interesting through error. It has this elements restriction on the children of for the lazy. It's because if we do it by ourselves, we cannot achieve this like a type restriction, since the React doesn't expose us with internal type systems, right? You don't have the access for this function component or this one. Maybe this one we could do like symbol for, but it's kind of hacky. It's not public. It might change over the time. So the first one is uh, the first reason is prevent unexpected types on the lazy. We cannot achieve this by ourselves. The second one is more important, I would say, is you can say like lazy. It just the sole purpose is like lazily loads the components. It doesn't want to add an extra fiber node like into the tree, right? So the thing is, if we implement by ourselves, like say, um, we have the lazy component, and inside of it we have the component, and then the component has a div. So you can see, it's like a three-level thing. This is one. This is original component. This is lazy component. This is the children of the component. We have different color here. But for built-in lazy, because for this lazy component inside, we will see that it aggressively reconcile as children inside of this component. So you can think of like these two components are put in one component, and then it will return its children as the children child of its child, so its grandchild. So for the pivot tree, the structure will be more concise. It will be two level. So I think the built-in lazy will be more elegant, because um, so this fiber layer will be omitted and possibly will improve the performance, though it doesn't matter that much because it's yeah there is not heavy work inside. But I think it feels more natural to just to put them into one. Great. So I think this is two differences. If you know more, please comment on this post or pin me on Twitter. Yeah, if you find this post helpful, please help me like share it to more audience. Yeah, that's all for today's episode. Hope it helps. See you next time. Bye.